So hi everyone, it's David. I'm the TA and I'm going to go over the solutions for this exercise. So the first thing, the first solution is going to be sort of for this algae is that they want to find how many cells are in the fourth level. And they should be able to see that there are, 0 red cells and 1 yellow. And then this yellow gives us 2 reds and a yellow. So we have 2 reds in the first level and 1 yellow. And so we have 3 total. And if you add those 4 cells together, you get 4. And then each of these red cells gives you 1 red cell. And the yellow cell, the new yellow cell gives you 2 reds and 1 yellow. So then now we have these 5 cells, and then so 4 and 1, 6 and 1. And then they should see the pattern is that the red is 2 times the level in each level. So the fourth level will have 8 red cells. The yellow always has 1 level, so you have 1, so you'll get a total of 9. And then the total accumulated will be 16 plus 9, which is 25. Okay, so then that's sort of the first question is how many in level 4? And the answer will be, 9 total. And then the second question is, will there be 1,000 red cells in level 100? And they should see that it's, 2 times the level, so there are 200. So there won't be 1,000 or more, which tells us that the cell will die. And then the third question that you will get to be asked is how many, the number of accumulated cells up to level 2 is 9. How many will be at level 10? And how many will be at level 100? So you should see that the numbers are following this. 1 is 1 squared, 4 is 2 squared, 9 is 3 squared. So the one way to see that is you can draw like this first square. And then if you draw a 3, that gives you another square. And if you draw a 5, that gives you another. And if you draw a 7, that gives you another. So then at level 10, there will be not 10 squared, there will be 11 squared, right? It's 1 more than the level. So there are 121. And at level 100, there will be 101, which is 10,201 cells. So that's sort of how you can answer this, but you want them to sort of do it on their own. You want them to see that you get evens on their own because you're always adding, you always have the red cells from this first one, and then you're going to add 2 more red cells from this new yellow cell. And then they should always see that there's always 1 yellow and that you get odds, and then you can explain them how the sum of the odds leads to squares. But you should ask them, like, you want to see, like, can they figure out that these are perfect squares, and then maybe explain because it might be a little hard for them to find this. So that is how you do the first exercise. And then for the second exercise, it's going to be that they get not 10 tokens, they get 6 tokens, and they can choose how many, they can both choose how many cells to start out with. And how red and yellow cells reproduce. So for instance, I'm given 6 tokens. I chose to have 1 yellow token, and yellow can have as many offspring as you want. So in my case, I said it will have 1 red and 1 yellow. So I've spent 1 token to get this yellow cell right here, 1 token so that each yellow cell gives birth to 1 red and 1 yellow. And then I took my 1 token to give me another red, and I made each red token give 2 tokens so that this red gives these 2, and then this red right here gives these 2. So then you can sort of see this pattern right here, and you can go over the table. So if you look in this case, my table is going to be, if this is red, level 0 was 1 red and 1 yellow, and then the total is 2, and the accumulated is 2. And then in level 1, I now have 3 red, 1 yellow, 4 total. So it's 2 accumulated and 6. And then in level 2, I have 7 red, I have 1 yellow, I have 8 total. That's supposed to be a T. And then I will have 14 accumulated. And then in level 3, you can the pattern should be 15, 1, 16, 30. And then you can ask them to continue on, and you can sort of see the pattern is that red is that the total you can sort of see is 2 to the level. So like or 2 to the level plus 1. So the first level, so the 0th level has 2, which is 2 to the 1. This is 2 to the 2. So this and then this 8 is 2 to the 3. And these powers are 1 more. So like you can do things with the table. You can do you can also do the graph. So you don't have to just use tables like I've been using. You can also use you can also sort of graph that here is what the red cells do. And then here the yellow cells do this. And then for instance, the red cells from the previous exercise, when it was 2n, do this. And you can also have quadratic. So these you can also use graphs to do it. So like, and then you can also, so then you want them to sort of figure out what's the best way to do it and what are different ways and how do they grow. So you can see that my level is like 30 versus the old one would have had just 16. So my level is growing faster. The accumulated in this case is going to be, I believe it is 2 to the level plus 2, and then that whole number minus 2. So like if you think this is 4, 8, 16, 32, so it's sort of 2 off from these numbers. And then the yellow is always 1. And it's probably easiest to do the yellow in the total and then try and figure out what red is and try and figure out what the A is. But you can also do, if you do, you can also, another way to explain things is to do it graphically. So let me, let me go to another page. So like for instance, when we had the yellow, 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 and each of these gave, 2 reds. So you had red, 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 red. You can sort of see that the red pattern was this. You can plot sort of that it goes 0, 0, 2, 4, 8, versus the yellow pattern is 1, 1, 1, 1, and that the total, and then if you want to do the total pattern, are these two just added together, and that and then you can sort of ask them to sort of see that these things are both on lot, or that these are all long lines. But then the accumulated pattern is sort of, it curves and it keeps on curving up. So if you look at the accumulated one looks like this 1, 4, 9, 16. So it's this curvy one. It kind of looks linear because of my poor drawing, but you can also use graphically to sort of see if there's maybe struggling with the table. So these are sort of 2 ways you can explain. And then for my one, you can also do like the exponential and see how those are 2 different curves, and that the exponential grows faster. So if if I do, if you had mine that was this, or maybe I'll go this one, you can do that. This thing graphically has the yellow that is flat, but then red, which goes like, my red goes like 1, 2, 4, 8, 16 versus the sort of the accumulated one from last one was like 1, 4, so let's see, 9. So let's see, that was 1, 2, 4, 9, 8 was 16. And then you, even though it looks like it's more, if you continue on, you actually will see what it should look like if I do the graph over here is that if I do, if I did it at a farther scale, it would, the black would do this thing. So they're both curving up, but the red will eventually dominate. Okay, well, that's this explanation. If you have any questions, feel free to come to office hours. Look forward to seeing you on Monday. Bye.